At some point, every powerful idea becomes dangerous, not when it is invented, not when it is understood by a few experts, but when it spreads. For most of history, cryptography was a tool, a quiet tool, a background tool, a way to hide messages, a way to protect secrets, a way to whisper instead of shout. It existed at the edges of power, not at the center. Kings used it, generals used it, spies used it, but ordinary people did not. And that mattered, because as long as cryptography was rare, it was tolerable. As long as it was weak, it was manageable. As long as it could be broken, it could be controlled. But the moment cryptography removed intermediaries, everything changed. The moment you no longer needed permission to secure something, it stopped being a tool, it became a threat. Every system of power depends on one thing: access. Access to money, access to communication, access to identity, access to records, access to history, access to coordination. If power cannot access something, it cannot monitor it. If it cannot monitor it, it cannot shape it. And if it cannot shape it, it cannot control it. Strong cryptography does not ask permission. It does not negotiate. It does not compromise. It does not make exceptions. It does not care who you are. It does not care what uniform you wear. It does not care what flag you live under. It only cares about keys. That is what makes it dangerous. The moment public key cryptography went mainstream, governments noticed. Not because they didn't understand it, but because they understood it perfectly. They saw what it meant before most people did. For centuries, states could intercept communication, letters could be opened, telegraphs could be tapped, phone calls could be listened to. Encryption existed, but it was weak, it was breakable, it was slow. Governments could always catch up. There was always a master key somewhere. Strong cryptography erased that assumption. Now two people can talk, move money, sign contracts, coordinate actions. And the state cannot see inside, not with warrants, not with laws, not with force. That is not a technical problem, that is a political nightmare. Because visibility is power, so a new idea appeared, a simple idea, a comforting idea. What if we add a backdoor? What if we keep the encryption but add access? What if only the right people can see inside? A backdoor is not extra security, it is not safety, it is not protection, it is not lawful access. A backdoor is a second private key, one you do not control. And the moment it exists, ownership changes. Cryptography is not like law. You cannot write exceptions into math. You cannot make it conditional. You cannot say only for emergencies. Math does not know intent. Math does not know morality. Math does not know context. If a backdoor exists, someone will find it. It may take years. It may take decades. But it will be found. And once it is found, it works for everyone. Not just governments, not just police, not just the good guys. This is not theory. This has happened again and again. Government backdoors leaked. Corporate master keys stolen. Secret access abused. Every single time. You cannot create a system that is secure and insecure on demand. It is either breakable or it is not. The debate is not about safety. It is about control. Who should hold the keys? Individuals, corporations, states. Because whoever controls the keys controls reality. If you do not control your keys, you do not own your money. You do not own your identity. You do not own your communication. You are borrowing access, and borrowed access can be revoked. Surveillance does not prevent crime. It records it, catalogs it, stores it. Strong cryptography prevents crime by removing opportunity. That distinction matters. The same governments that demand backdoors use the strongest cryptography themselves. Military grade, unbreakable, no backdoors. Think about that. Privacy for power, transparency for everyone else. Public key cryptography exists, one-way functions exist, hash functions exist. You cannot uninvent an idea. So power adapts. If it cannot break the math, it attacks the edges. Key storage, user behavior, legal pressure, compliance, fear. Humans are easier to hack than equations. This was never about math. Math was just the battlefield. This was always about who gets to decide. And now that you see it, you can't unsee it. If this made you uncomfortable, that's the point. If this made you think, pause the video for a second, then like it. Subscribe if you want more of this series. Comment below with the words, "Who controls the keys?" and share this with someone who still thinks encryption is just about passwords. Because once you understand this, you realize something important. Neutral systems don't threaten power. Uncontrollable ones do. And the moment you understand who controls the keys, you understand who controls the future. Everything you've learned so far assumes one thing: that the math will always hold, that the problems we rely on will stay hard, that forward stays easy, that backward stays impossible. But what if that assumption breaks? There's a machine that does not think like a computer. It does not count like a computer. It does not follow the rules your intuition depends on. It is called a quantum computer. This is not hype. This is not science fiction. This is not a faster laptop. Quantum computers are a different universe of computation. Everything you use today runs on bits, 0 or 1, on or off. That limitation is why cryptography works. Quantum computers do not obey this rule. They use qubits, not 0 or 1, both. At the same time, a qubit can represent multiple states simultaneously, not metaphorically, literally. It explores many computational paths at once. This is where intuition breaks, and this is why cryptographers are afraid. Modern cryptography depends on hard problems, factoring large numbers, discrete logarithms, elliptic curves, problems that are easy to do, and brutally hard to undo. Hard for classical computers. Quantum computers do not play by those rules. In 1994, a mathematician named Peter Shor proved something terrifying. A sufficiently powerful quantum computer can factor large numbers efficiently. That one sentence changes everything. RSA collapses. Elliptic curve cryptography collapses. Public key systems as we know them stop working, not partially, completely. This does not mean it happens tomorrow. Quantum computers today are limited, fragile, noisy. They cannot break global cryptography yet. But progress does not stop, and attackers do not wait. There's an attack most people never hear about. Harvest now, decrypt later, encrypted traffic is recorded, messages stored, transactions archived, waiting for the math to break. Time becomes the enemy. Some secrets expire, others do not. Medical records, biometric identity, state secrets. Once exposed, they cannot be unexposed. This is why post-quantum cryptography exists. Not panic. Preparation. Cryptographers responded the only way they know how, with new math. Post-quantum cryptography is designed to survive quantum attacks, not by secrecy, not by trust. By choosing problems even quantum machines struggle with: lattices, hash-based signatures, code-based systems, multivariate equations, different math, same philosophy, easy forward, brutal backward. But there's a cost. Post-quantum systems are heavier, larger keys, more computation, more complexity, more room for human error. Transitioning is dangerous. Switch too early and systems break. Switch too late and everything breaks. This is not just a technical decision, it is a civilizational one. But here is the deeper fear. What if quantum is not the end? What if every cryptographic assumption eventually breaks? Cryptography is not eternal. There is no final algorithm, only delays, only margins, only time bought. And this is why this matters, because cryptography is not just math. It is the foundation of trust in a world of strangers. When cryptography fails, trust fails, money freezes, identity collapses, communication fractures, not slowly, instantly. This is why cryptography is never finished. It is an arms race between computation and mathematics, between power and structure. At the beginning of this series, you thought cryptography was about passwords. Then you saw it was about math. Then you saw it was about power. Now you see it is about the future. So here's the final question. If trust is built on math, and math is temporary, what does humanity trust next? If this made you uneasy, sit with it. Then like the video, subscribe for the epilogue, comment below with the words, "when the math breaks," and share this with someone who still thinks this is abstract. Because when cryptography fails, it does not just break systems, it rewrites civilization. There is a moment after you understand something dangerous, not when you learn it, but when it settles, when the noise stops, and the implications remain. That is where you are now. Because once you understand cryptography, you realize something unsettling. The modern world is not held together by laws. It is not held together by morality. It is not held together by trust. It is held together by assumptions. The assumption that the math works, that it keeps working, that it will work tomorrow the same way it works today. Most people never think about this. They do not need to. Cryptography was designed to be invisible. It never asked for attention. It never asked for belief. It just worked until it doesn't. When that assumption breaks, nothing fades slowly, nothing warns you, nothing asks permission. It stops. Money does not disappear. It freezes. Identity does not vanish. It fragments. Communication does not explode. It fractures. And most people will never know why. They will blame hackers. They will blame governments. They will blame companies. They will not blame math. Because they never knew it was there. Understanding this does not make you safer. It makes you awake. And awareness is not comfortable. Once you see structure, you cannot unsee it. You notice when power says, "trust us," but cannot explain the system. You notice when control hides behind convenience. You notice when obedience is easier than understanding. Ignorance was comfortable. Understanding is not. Most people will never ask who controls the keys. They will not want to. Because that question forces another one. If trust is mathematical and mathematics is written by humans, who do you actually trust? This series does not give you protection. It gives you clarity, and clarity is dangerous. Power today does not wear uniforms. It does not shout. It does not threaten. It compiles. The biggest lie of the digital age is that this is neutral. It is not. Every equation encodes values. Every protocol encodes power. Every system chooses winners. And now you know. That knowledge does not make you special. It makes you responsible. If this series changed the way you see the world, pause for a second. Like the video. Subscribe if you want more work like this. Comment below with the word clarity. And share this with someone who still thinks trust is automatic. Because once trust is mathematical, ignorance is a choice.